Hi everyone. So we're on to a brand new M1 topic, which is involving impulse and momentum. And really we need to start by, well, what is impulse and what is momentum? So we'll start with momentum. It's something we've all heard of before, no doubt, and have used it in sentences, in our normal daily lives, but not necessarily knowing what the definition of momentum is. And it took me a long time actually of investigating, asking around the physics department, because I didn't do physics at college or university, and so when I started learning this, I was in the same position as you in some ways, um, and it was like, what is momentum? What is it? And literally, all momentum is a definition. It's a definition. So the definition of momentum is rho, which is like this kind of slanty p. So rho is mass times velocity. So mass times velocity. Now, a good way to describe this, I heard someone use this description, and I quite like it, was the idea of mass in motion, basically. Momentum is mass in motion. And if you think about it, uh, I asked students once before, describe what you think momentum is, and one of them put up their hand and said, the amount of force you would need to stop a truck coming at you, kind of thing. How hard it would be to stop something which is flying at you. And that seemed like a good description. The amount of momentum that something um, generates. I mean, if you think about X-Men, I don't know if you've seen X-Men, but when Vinnie Jones, the footballer, is Juggernaut, he describes himself as Juggernaut, and Juggernaut, his mutant power is that once he's in motion, he's got so much momentum that it's impossible to stop him. Basically, nothing can stop him. Um, so that is how I think of momentum. The amount of mass in motion is kind of a measure of how difficult that thing would be to stop, let's say, or to slow down. Um, but it is literally mass times velocity. Uh, what's its um, what's its unit of measure? Well, its units of measure is called Newton seconds. So NS, Newton seconds. Why is that? Well, mass is in kilograms, isn't it? Velocity is in meters per second. So if we put MV together, that's kilogram meters per second, isn't it? What is a Newton? A Newton is the amount of force required to accelerate 1 kilogram 1 meter per second squared. Okay? So you could write this, because remember this is kgm over s, isn't it? We could write this as kgm over s squared all times s. And this is newtons, isn't it? A newton is the same as kilogram meters per second squared. So our unit of measure from now on is Newton seconds for impulse and momentum. Okay? Let's continue. So it says find the magnitude of the momentum of, it's comparing a cricket ball of mass 400 grams, but we always work in kilos, and a lorry of mass 5 tons. So let's compare. So the cricket ball, so rho for the cricket, so we'll call that rho C, is its mass is zero point 0.4 kilos and its velocity is 18. So zero point 0.4 times 18, it is 7.2 Newton seconds. Yeah? Whereas for the lorry, 5 tons is 5,000 kilos times by 18. So 5,000 times by 18 is 90,000 Newton seconds. So one of these you're going to want to catch in midair, and one of them you're really not going to want to catch, okay? Because uh, it will slam you big time. Anyway, okay, so that's momentum. Quite a simple definition. What's impulse though? Impulse is described as the change in momentum. So impulse is this, if you imagine a gun, let's say a gun, you pull back the hammer of the gun, you pull the trigger, and there's a spark. There's a spark, yeah? That spark injects a change, doesn't it? A chain reaction which will change the momentum of the bullet and the gun. The bullet will fly out and the gun will recoil. Okay, so impulse is an injection, a spark, that will change momentum. So it's an injection of force for a certain amount of time. So impulse, the formal definition of impulse is Ft. Okay? So when you hear impulse, you think Ft. That's one definition of impulse. So as soon as it mentions time and a force, you know it's talking about impulse, because think about it, if I kick a football, let's say, laces on the ball, you know they say kick through the ball, you know, or golf, strike the golf club through the ball. What you're trying to do is you're trying to increase the amount of time that your foot or the club is in contact with the ball, you see? So therefore you generate the most change in momentum, the most, I don't want to say power, because that's a different definition, but do you see what I mean? You are increasing the amount of time that that force is acting on the particle or on the object, and therefore it's going to have a much greater increase in its momentum. Now, we can generate what's called the impulse momentum principle. So at the moment, this is just impulse, but there's something else we can glean from this. Love that word, glean. Because we know that F is ma from Newton's laws. So if we replace F with ma, we get I equals mat. Now, what is A? If we're talking about constant acceleration, we can change our A from our Suvat equations, can't we? We know that V equals U plus AT, and therefore A equals V minus U all over T, doesn't it? So therefore, I equals M V minus U over T. That replaces our A all times T. So now we have I equals MV minus U. This is called the impulse momentum principle, which we'll call IMP from now on. So if I expand this out, you'll see this is MV minus MU. So can you see? This is final momentum take away initial momentum. So you can clearly see that impulse is in fact a change in momentum. So impulse you can think of as change in momentum. It's the spark that occurs that will make that happen. Okay? And we can do an example using this thing. So the example on the board here says a body of mass 2 kg is initially at rest, so that's good, so we know U is 0, on a smooth horizontal plane. A horizontal force of magnitude 4.5 newtons acts on the body for 6 seconds. Find the magnitude of the impulse given to the body by the force. It's mentioned a force, it's mentioned a mass, it's mentioned a time, it's mentioned initially, all this stuff. Which stuff do we use? As it's asking for impulse, we know two definitions for impulse now. These are our two definitions. Which one do we want? Well, we want the first one because it says the force is acting at 4.5 newtons and it acts for 6 seconds. So our impulse is 6 times 4.5, so that will be 27 newton seconds. Because momentum is measured in newton seconds and impulse is involving momentum, it makes sense that it's going to have the same units. Okay. Find the final speed of the body though. the final speed of bodies involves velocities. And therefore we have to go back to our second definition of I equals mv take u. So we know that, so I equals mv take u. We know that the magnitude is 27. We know the mass is 2. We don't know the final velocity, and we know it started at rest before the force came into effect. So therefore, if we rearrange, we get 27 is 2v, so therefore v is 27 over 2, which is 13.5 meters per second. And there we go. Let's do another example using this then. So a ball of mass 0.2 kg hits a fixed vertical wall at right angles with speed 3.5 meters per second. Start drawing a picture. So here's a wall. That's how you can represent a wall. A particle hits that wall at right angles. Particle is circular. And it's got 0.2 kg. So this is exactly how I want you setting out these kind of problems, okay? With speed 3.5 meters per second. So u is 3.5 meters per second into the wall. The ball rebounds with v, so final velocity, 2.5 meters per second. So notice my arrows are dictating my picture. Everything is about the picture in M1 and M2. The arrows are dictating the direction that these things are moving. It says find the magnitude of the impulse exerted on the wall by the ball. So let's think about it. The ball hits the wall. An impulse occurs, doesn't there? Something sparks there that reduces the speed of this ball as it comes out of the wall. So there is an impulse exerted on the ball, but there's also an impulse exerted on the wall, isn't there? Equal and opposite reactions, going back to our Newton laws again, okay? So, impulse is always coming out of the bodies because the ball is being pushed away from the wall, isn't it? So the impulse is sparking the momentum outwards. And that diagram will now tell us everything we need to know. We need directions now. So we know I is mv take u. This is imp, isn't it? So we're going to apply imp in the direction, always in the direction of the impulse in question. So we're using the at the ball, yeah? So I quote imp, the direction at ball. There are lots of people who are not putting directions down in their resolving and stuff, and that's why you're messing up. And that's why I've got, you know, I'm not going to talk to you or help you until you start putting your directions in. It really is for the best, and you're trying to communicate. Try and communicate with whoever's reading your work, which direction you're going, and it helps you work out what's going on yourself, and it links to the diagram that you've drawn. So everything is relative to the left. So I equals mv take u, which implies I is your mass, 0.2. V, is V going in the direction of the left? Yes. U, so minus, is U going in the direction of the left? No. U is going the opposite way. So therefore we get 0.2 times 6. So therefore we get 1.2 Newton seconds. Okay? There we go. That's impulse. Now, I think we'll put this one on another video.